An example for this Mean-Ergodic stationary. Consider a random process with the autocorrelation function like that. So remember that from here you can calculate Rx of 2 is equal to mean of x. Mean should be constant to the power of 2 plus Cxx of 2. So we have always this relationship. So if it says White-Sands stationary, that means that mu x is constant. It's not a function of time. Now we want to see if this is Mean-Ergodic or not. So what we do is that you can plot this random process and you see that you have 2 exponential, 1 left-sided, and so on. And then you have to multiply it by a rectangular pulse, as you saw in the theorem, and then this rectangular pulse starts like that. So let's say this is minus t and this is plus t. So multiply 1 minus like time 2 divided by t, and then Cxx of 2, and then calculate this integral from minus t to t. Remember that if you multiply this rectangular pulse by the exponential one, okay, the support of the rectangular one is minus t and t, okay, and then d2, you calculate this integral. If it is a finite number, it is Mean-Ergodic. Obviously, because this is 2 exponential, you get 2 curves and it's finite, and then you can get. So this is Mean-Ergodic process. This is a Mean-Ergodic random process because 2 bounded functions or that, so kind of like. So what we do is we calculate the integral, so this should be what we do, we calculate this integral, and if this is converging, then it is Mean-Ergodic, and if it is not converging, it is not. So you calculate this integral, you replace this by e to the power minus 2a 2, and because this function has 2 definition, is equal to plus 2 when 2 is positive, and it's minus 2 for 2 is negative. So you have to split this integral in 2 integrals and then calculate it. What happens is that whatever value you get for positive values, you get for negative values, because these 2 functions are both even. So if you do that, you get this expression, and now you can see that this will converge as t goes to infinity. You get a bounded number. So it is easy that the limit of the above is equal to 0. So therefore, you have mean. So x of t is mean periodic random process in mean square sense. So similarly, the ergodicity could be defined for other statistics and in other senses, but some of those definitions may be useful, some of them may not be useful.